Labs. Guys, do you know when people say save the best for last? Well, this talk is called Fighting Software Entropy. Building software is the easy part. Evolving and maintaining it is the hard part. I mean, I think that most of us can agree with that, right? Preferable approaches change, team members leave, tech debt accumulates, ownership changes, and everyone has a lot of other work on their plate. Software decay is a very real and endemic problem for us all. So, without further ado, let me introduce you to Stewart Gleadow. Stewart is Executive Manager of Engineering of the Customer Marketplace Experiences for Buyers, Renters, and Sellers on realestate.com.au, directly from Australia. Stu, would you care to join us? Let's give him a round of applause.
Thank you. We just had a few nervous moments to start, but my HDMI adapter chose today to break. So that was a little bit scary, but we're in action now. So I'm Stewart. I've come here from Australia. It took me about 30 hours to get here because I had a really bad connection. I work for a company called REA Group. We do online real estate. Realestate.com.au is our biggest brand. That's the one that I manage the engineering teams for, but we have teams all over the globe. Sorry, I gave this talk at home last week, so I use that way, but I think you guys... can I spin it? Yeah. There we go. That's actually, they're actually the rest of the world is there. It's just really pale. So we're in Australia. We own, an equivalent business in REA India, and we've got a stake in Southeast Asia and America as well. So there's a few thousand employees, lots of software, and we've been around for quite a while. And really, this talk is around, like, how does that software age over time, and how do we manage that so it doesn't get into that unhealthy, unmanageable state. So this is me. It's really lessons learned from maintaining software at scale over the last 15 years. Someone said, if you wanted to say you've been doing this for 15 years, here's a photo of you 15 years ago. So I really like the physical card walls. I miss that now that everything's digital. But yeah, so I haven't aged a day since then, which is nice. So let's talk about the life of successful software, because as a successful business, if your business and those products are successful, the software tends to hang around. And that means we have to deal with that and how those changes over time. And so this is a graph of how happy developers are working in your code base over time. And obviously at the start, it's great. Everyone's happy. You can make all the decisions. You're like, oh, we're going to use Rust, and it's going to be amazing. And then over time, reality bites. There's trade-offs that you have to make. And things gradually deteriorate. Every now and again, there's a little uptick. There's some kind of uplift project or something like that, and everyone feels really good about it. But ultimately, things tend to decay and get worse over time as software ages. And we talk about this, what is this time to legacy for your software? Is it measured in months or quarters or years or even decades? And how do we maintain that over time? And so when I was thinking about this with a colleague of mine back home, and we tried to use this analogy from physics around entropy and how that might apply to this same concept. So entropy, so this is Rudolf Clausius. He was a German mathematician that came up with the second law of thermodynamics and talks about entropy being a measure of disorder in a system, and with the characteristics that systems tend to inherently move to disorder. And the more disorder that's present, the less energy is available to do useful work. And so it's not a great thing in our software. So we think that, and so if you want to use that example, a kind of a physical example, a structured system has much lower entropy. So a sandcastle is very unlikely to just appear without a mold and effort and things put into it. And so that's a kind of a low entropy state. And that might stay there for a bit, but over time, the seagulls come, the wind comes. We go to the beach a lot in Australia, and it tends to just deteriorate over time. And that's the kind of high entropy state and the more likely state. So my colleague Alison and I started talking about software entropy, really using these same things, that if we want this structure in our software, that software entropy is really the measure of disorder in software, and it has the same characteristics that we observe over time, that software inherently moves to disorder. And the more disorder that's present, the less energy is available to do useful work. And we see that where it becomes harder to ship new features and to build products into these older systems. A lot of what I'm going to talk about how we do this and measure it is actually the brainchild of Alison here. She wrote the talk with me, but she's got a young child at home, so she had to stay here, stay back in Australia. I've got 4 young children, so I was very keen to get on a plane and come over here. I haven't slept so well in 9 years. So let's talk about, so structured software would have lower entropy, because that's the kind of less likely state to be in. And it's really, if you think about modules and interactions between them, that it's really our software architecture that's defining that modularity and interactions between them. So architecture is a really key part of this modularity and of this entropy. And this is really observed as something that makes it easier to ship software. So the State of DevOps report, this one's from 2017, but it's come up multiple years, that high-performing teams were more likely to have loosely coupled architectures. And so loosely coupled would imply that there are these modules, that there's these well-defined interfaces and boundaries between them. And why does that software decay? Just over time, you make compromises. I'm sure you'll come back to code that you wrote a few years ago and you think, what was I thinking? Those trade-offs, they seem really sensible at the time, but they'll come back to bite us. Your dependencies date. Just the approaches to building software changes over time. So some of our software is 10, 15, 20 years old. It's the way we write software now and run it in production is very different to when that software was written. And one of the big ones is that shared understanding is lost. There's always this change in stuff over time. I've really enjoyed staying at an organisation and watching that progression over time, but a lot of people move around, and so the people maintaining the software aren't necessarily the people that wrote it. Actually, this isn't a new observation. So there was this research from Maya Lehman and Laszlo Belady at IBM, I think it was in about 1972, where they looked at these laws of software evolution that they saw from observing a whole lot of code bases. And they said that these things that they saw in all cases were that as software evolves, there's continuing change, but increasing complexity. Continuing growth, but declining quality. So that increasing complexity and declining quality, that's really that decay into the high entropy state. And they actually said, that is almost guaranteed to happen unless you do deliberate work to stop it from happening and to maintain that structure. And that's what we're going to talk about. In terms of how it affects building features over time, as Martin Fowler wrote a post in 2019, basically said with most software systems, it becomes harder to add new features over time. And the example he gave really ties in with this entropy analogy. So he talks about a clean system and a crafty system. Might say an ordered system and a disordered system. And in a clean system, it's very easy to grab bits of that system and string it together to build the functionality that you want and to ship the product features. But in a crafty system, you have to work around all these other bits all the time. And it's actually much harder to get useful work done. And why should we care? I found a survey that Accenture did a few years ago where they asked a whole bunch of IT executives what they thought about different questions about tech debt and the state of their technology, and they could answer how they felt about it. But there's lots of interesting data in there, but the question that I thought really captured the futility that we can sometimes feel, it basically said, do you agree with the following statement? I would like to tear up all of our organization's core systems. And just think as a question, you can just feel, I've certainly felt that in the past. And so the people that they surveyed, 81% of people said that they agreed with this statement. And actually, 17% were neutral. Only 2% of people actually disagreed with this statement. And so that feels a little bit disappointing as an industry, that essentially 98% of people, let's just throw it all away and start again. And so that's the challenge that we're up for. And this is a challenge that we've been facing into at REA, because the more software you have, the more entropy you're going to have, the more software there is to manage. So this is a graph of the number of different systems we have. You can see kind of when we started scaling, people like James Lewis said that microservices were a good idea. He's floating around the conference somewhere. And we did that. We built a lot of services, but they were all different. Then we shifted to an internal platform strategy. That's made things a lot more aligned and similar and is really managing that sprawl. But there's this ongoing growth. We're a growth company. We have ambitions to continue to grow. So there's always going to be more software being written. So we need to manage that. And the other thing that has a big impact is like varying technologies. Every different technology you choose comes with an ecosystem with libraries and dependencies. And so the more different things you have, then the more kind of entropy you're going to have to manage with your software. So I think these are all things that we use at REA, other than we actually retired our last backbone system just recently, so I should probably remove that. But there's probably other UI frameworks, some JavaScript frameworks if I look hard enough. So they're all different technologies that we use at REA. And so increasing entropy is the likely state. That's the natural thing that would happen, that physics would say is going to happen to our software. But decreasing entropy is possible in an open system. So if we put energy in or matter in or structure, we can actually decrease that entropy and keep and drive that structure in our systems. And so how can we fight software entropy? It's really about defining the structure of the software that we want and putting energy in to maintain it. This is unrelated, but I saw a sandcastle like this on the beach with my kids a couple of years ago, and everyone was standing around taking photos of it because it's so amazing. And my kids ran up to kind of look at it as well, and everyone's looking at it, and then suddenly my kids just ran in and jumped on the sandcastle and destroyed it for everyone. So I feel like my daily life is a lesson in the kind of this decay into chaos. I've got 4 boys under 9 years old. All right, so that's the kind of scene set on what we think about software entropy and the systems we've got to maintain. I'm going to talk about a few different areas where we're using that to kind of, we're saying, to fight software entropy. And the first is around architecture. I think that's really important. We're going to talk about engineering excellence, continuous improvement, and our platform strategy that I mentioned before. So architecture is defined as the design and structure of a computer system. And so if we think that having that structure is the low entropy state, the less likely, then architecture is actually really important. And it's unlikely to appear without some help. And so you need some principles to do that. There's been some talks today that talked about, you don't want that ivory tower architecture. You really want to push decision making into the teams. So we have some architecture principles that we use that we think are the important things that we really care about in defining our systems. Then we allow a lot more decision making kind of in the individual teams that are working on the software. And so these principles are all documented in a fairly simple way, just with a short name, a little explanation of what it is, why it's important, and then some practical examples about how that shows up. So just to give you an example, this is one that I really like. It's just called Keep It Clean, and just says that constant cleaning is part of work well done. This is actually an expectation of how our developers should work. If you don't do the work and then shove the other work on some tech debt backlog that never gets looked at, do the work when you see it. Leave things better than when you arrived. And the incremental improvement, no matter how small, that adds up over time. It compounds. And it's a really healthy habit. So that could be things like adding or improving documentation, fixing some static analysis, increasing test coverage, tuning monitoring, but it could be very many things. So this is the full set of architecture principles that we have. So adopt the platform is really around, don't reinvent the wheel. If people have already solved that problem, just adopt that. We have some internal platforms, but it could also just be, for this kind of thing, just use this thing in AWS or in GCP. Make it approachable. We've got a real emphasis on documentation and making our systems approachable, kind of for future us and for the new developers as they come onto the team. Building security in, that really shift left of security, build it in from the start, don't do it at the end. And managing your data, or data I should say, increasingly, all companies are becoming data companies, and so how you manage that and how you leverage that through your organization is really important, but also being able to do that, but still with the trust and consent of the people, the customers that are providing that information. Deploy continuously. I haven't looked at the latest stats, but almost all our software, other than a few cases, is continuously deployed. As soon as code is merged, it'll run the tests and ship to production. And then map the business domain, really focusing on understanding the business problems and modeling that business problem, getting that ubiquitous language, and understanding those bounded contexts before you worry too much about the technical solutions. Keep it clean, the one I just mentioned, and loosely couple we actually just added in the last year, and it's really part of a push towards having a more event-driven architecture throughout the company. We've had various event-driven systems for many years, but there's much more of a push to kind of shift away from synchronous coupling between our systems and having events flowing through that. So that's a kind of a new principle that we've put in to try and kind of push us in that direction. And there's a few other things in terms of trying to drive that alignment, just around, it's really important to have a long-term technology strategy that people agree on where we're going for the long term, and that those principles are actually actionable things as we build software to help us get there. To having good decision-making frameworks, understanding the choices that are being made in all the different teams. There's no way a handful of leaders could keep up with all those decisions, but just having the right frameworks that surface important decisions, but still allow those autonomy in the teams. Having good knowledge management, documentation, making things approachable. And sensible defaults is one I want to cover. So when you look at that graph I showed before about our explosion of systems, initially that all grew through very unconstrained autonomy. It's just teams could just grab whatever they want, build systems, ship them to production. And that was very good scaling for 4 or 5 years, but has left us with a lot of software to maintain. And so there's a much more of a push now to understand, well, what are the things that are differentiating for your products, and really you need to make those decisions, and what are the things that really should just be the same. And trying to relieve our teams from having to make too many choices all the times. That just went about 3 slides ahead, sorry. All right. So I really like this quote. So Ellen Ullman was a software developer back in the 70s. She became an author. She wrote some things about the Y2K bug in the 90s that basically said, the Y2K bug, it wasn't really a bug. It was actually a really sensible design decision for many decades, until it wasn't. But she also said this, that people who have no choice are generally unhappy. But people that have too many choices are almost as unhappy as those who have no choice at all. So I think there's this balance around how much freedom do we want every team to have. We want autonomy to be able to drive product outcomes and business outcomes, but we don't want to have to make every decision on every project. So the way we do that is through an internal tech radar, and really we talk about supporting freedom from choice as well as freedom of choice. Obviously this is inspired by the ThoughtWorks tech radar that they use to discuss interesting technologies that are coming onto the market that they're using with their clients. We use it to map what are the things that are kind of sensible defaults for us to use, what are we experimenting with, what are the things that we're actively moving away from. So we have a similar kind of product internally. It doesn't have nearly as nice a UI. And a little bit different to ThoughtWorks, when things are no longer interesting to talk about, they kind of drop off the ThoughtWorks tech radar. But we use this as kind of our inventory of technologies that we use. So they actually only disappear from this when we actually don't use it anymore, when there's nothing of it left. And so we end up with a lot of blips over time. And so just to give you an example, if my clicker works, there we go. So React is a good example. Over time, particularly about 10 years ago, there's this real explosion of UI frameworks. We tried a lot of different things, but over time, many of our teams just started to consolidate on React, and at a certain point, it just made sense to say, if you're building a web UI, just use React. That's the case at the moment. That might change in the future. This radar has, rings for experimentation and trying new things and learning new technologies. So it's not meant to stifle innovation, but for most people and most projects, at REA it just makes sense to use React. In your organization it might be a different framework, but it probably doesn't make sense to use 5 different frameworks because they all come with their own ecosystem. So that says at the bottom, so React is the sensible default for building user interfaces at REA. There's also this bit in the middle that says React is the foundational technology that our web platform and design system are built on. And so that'll come into some of our internal platforms that I'll mention in a bit. So those principles and the radar, they kind of define a little bit around what we're aiming for, what that structure looks like. But we know we have to, it's an open system. We have to put energy in to make it show up. It's unlikely that a sandcastle will just appear. And so a lot of that comes from our architecture function, or I would say that all of our developers are doing architecture every day. It's just the scales that people work at. So we have a set of architects that are embedded in the business unit. So I've got, in the group that I manage, I've got 3 architects that work in that area, and that's their home. But 20% of their time is allocated to kind of central enterprise architecture and alignment and technology strategy. And that investment of time is really valuable to try and connect the dots on lots of little decisions that are being made across the organization and seeing something that makes sense here doesn't make sense over there. And so they're not ivory tower architects, they're in the business, feeling the same problems, but they have some time to connect and collaborate. So that's a bit about our architecture. So architecture alignment, we feel like that decreases software entropy, and that the principles increase consistency of decisions, so there'll be less divergence. And that freedom from choice with something like a tech radar, sensible defaults, that reduces cognitive load. But all of this doesn't show up without effort. So dedicated time is required to drive these outcomes. If you want that alignment, if you want that similarity and that structure, you're going to have people that have dedicated time to do this. It can't just be a kind of hobby project on the side. All right, let's talk a little bit about engineering excellence. It's really about talking about what do we mean by good software, and that will be different in your organization and other ones. We started talking about this about 10 years ago, and we actually just drew all of the systems on index cards, because we were all in the office, and just said, like, do we think it's good? Do we think there's problems? Do we think it's awful from a technology point of view? And we used red cards if it was like kind of legacy systems that we didn't like. And then we just drew it all up on the wall and drew lines in between it. And we couldn't do it now because there was too many systems, but this is all the software at the time. We're a two-sided marketplace with kind of real estate agents on one side, members of the public, consumers on the other, and joined in the middle. And actually this visualization was really powerful. People could come and look at it and say, gee, if I'm working in some area it's mostly red legacy, that's going to be hard. Or I can go through and look at the health of some of them and say, if most of these systems are unhealthy, it's actually going to be much harder to do this work. And the other thing we did at this is we started talking about system health rather than tech debt. So tech debt, I feel like is a really interesting concept and a great metaphor. But debt is used in businesses in weird and wonderful ways and not necessarily seen as bad. But unhealthy systems does sound bad. And so when people from risk and audit hear about you've got unhealthy software, that actually triggers much more strongly than when you talk about debt. And so that's actually been a blip on the tech radar, the ThoughtWorks tech radar recently, referencing this work, talking about systems health over tech debt. And it's unrelated to the talk, but for 10 years we've been trying to get rid of this set of systems in the middle, and finally last week we turned off this kind of old JBoss ESB from 15 years ago. It's got some of my code in it still, and finally we stopped using it last week, and I asked one of the developers, I said, can you wait till I'm back in the office and we'll get a big red button and we'll have a big ceremony and turn it off? And he said, no, it's costing us money, I'm just going to delete it. So it's gone. So that's unrelated, but I was just really excited. That's kind of a 10-year journey finally done. So initially what we did was we just asked people, do you think the software is healthy or not? Is it good, problems, or awful? But actually we need to be a lot more clear than that and remove ambiguity. And so over time we tried to get really clear around 3 different lenses that we think about our healthy software. So development, can I confidently and safely make changes, particularly for new people? Can you go in there and make changes? Or if you're on call in the middle of the night and you have to make a change, how easy is that? When there's many systems, you're not familiar with all of them. Operations, we have a culture of you build it, you run it. So can I support the system and confirm that it's actually working in production? And then architecture, is the design extensible and fit for purpose? Does the system actually make sense in that context? And so they're the 3 lenses that we assess, and we have a set of criteria across each of them. around what we think makes good quality software. And all our teams rate their systems against this. And so over the years, we've tried to make that more and more objective and very specific around what we mean by these different characteristics. So what we assume when teams come to rate their systems is that software starts unhealthy. There's no assumption. I think before that, when it was just asking people, do you think it's healthy? I think when teams are like, yeah, of course, yeah, my software is pretty healthy. If you give it to someone else, they might not think that. So we assume everything starts unhealthy, and then you have to answer a set of questions around criteria. So these are quite just sanitized versions of it, and we're not going to go through every one, but things like continuous integration, obviously that's been something we've done for a long time. Containerized development environments. So as someone who's worked across a lot of different systems over time, just being able to jump in and run things in Docker has just been a kind of a godsend. It's been really great. But there's a bunch of things around, system recovery, logging, support documentation, and then, actually, does the architecture make sense, have a well-defined interface? So if you can answer all those things, you get an amber rating rather than red, and then there's a set of more things. And we reflect on this and add to it over time. And so continuous deployment is up there. As I said, that's a really keen, a big practice for us. Up near the top left are kind of multiple deployments and multiple contributors. I really like them because software that isn't worked on very actively, that tends to get unhealthy over time. So having multiple people working on it and deploying it regularly, actually we find maintains healthier software over time. So that's just a screenshot of an internal catalog. It's kind of an instance of Backstage. So teams would go in for all of their systems in the catalog and answer some questions each time. And then we give teams time to keep their systems healthy. And that's a really important thing in our engineering culture. There's this quote from Deming that says, all anyone asks for is a chance to work with pride. There's an old video of this talk, like an older version of it, and one of the comments of it was, I've never heard of REA, but now I want to work there. And I found that really nice because I think this culture of improvement is really nice. It was on YouTube. There's probably terrible comments as well, but I didn't read them. But there was a nice comment. And I couldn't believe my good luck when I Googled photos of Deming, and as an Australian, I found a photo of him either like cuddling or boxing with a kangaroo. So yeah, I had to leave that picture in. All right, so that's a bit about engineering excellence. It's really about agreeing what engineering excellence means for you, and then radiating information, building that shared understanding of the health of your software, and then using objective measures as a baseline for improvement, and that really helps to build that culture of engineering excellence. All right, let's talk a little bit about continuous improvement, because once we've got that baseline, we really want to improve the health of our software and maintain it over time. That's because the passage of time increases entropy, as we talked about. This is a histogram of the number of systems by age across REA. So you can see, I actually had to cut it off at 15 years. We do have some software from the 90s that's still running. It's older than a lot of our staff now. But a lot of our software is 1 to 7 years old. And that's old enough that those shortcuts that you take or decisions or just drift in the industry and the tooling, that all starts to happen through that time. And so we need to put in effort to actually maintain those systems. There's a great blog post from Marty Kagan, way back in 2007, but it said the deal with engineering goes like this. Product management takes 20% of capacity right off the table and gives it to engineering as they see fit. And if you're in really bad shape today, you might even need to make this 30% or even more. And he goes on to say, I'd be worried if I think teams can get away with much less than 20%. And so that's really interesting. And we do have teams, over time that think, well, maybe I could get away with less than 20%. And we'd actually really rather prefer they didn't, and we've got good buy-in through our leadership that actually we want to invest this 20%. I've got a couple of teams that actually like to spend about 30% on kind of maintenance. That could be reducing risk, paying down tech debt, lowering the total cost of ownership. And so we kind of have this 20% custodianship budget that's essentially built into our system of work and expected that our teams will spend that time. And then every quarter, we rate the system once a quarter, analyze the health, and we look at, well, what's the work that we would need to do to improve that? And we drive that over time. That's just a couple of screenshots of things that are happening in Backstage that might just show summaries of, this is for a certain team. How are they answering those questions? I can't remember which team this is, but I can see right down in the bottom right that they've got 4 systems where the kind of cost optimization for their AWS infrastructure hasn't been done. I'm accountable for meeting our infrastructure budget, so I'll follow them up when I get back to Melbourne. And then you can see the overall health ratings over on the right. And seeing that change over time. So we can see that this is a Sankey diagram. So this is maybe like I think this is from the start of the financial year to now for one of our teams. But at the start of the financial year, they had mostly red and yellow, or red and amber systems, and some green. And over the year, with this effort they've put in around looking at their health criteria, which ones are they failing, coming up with plans and putting in the time to fix them, they've actually managed to move quite a bunch of their systems into green. They retired a system. That's always exciting. I get very excited about turning off software. And what's really nice to see is that the new systems that they've created have been created in a green state. So we don't want to be creating new software that's unhealthy. That's just writing checks that we're going to have to pay off later on. So I forget which team this is, but I'll have to give them a pat on the back. They've done a really good job this year. This is a high effort exercise, over 1,000, 1,500 systems. So certainly the more you can invest in automation, the better. Things like Renovate that can automatically open pull requests for dependencies that need updating. We use BuildKite for our CI/CD, but when we talk about having regular deployments, just a lot of our systems are just deployed weekly or fairly regularly, just scheduled. Even if there's no changes, we're just always deploying the software, just so we've got confidence that if we have to make a change and do something, that we can do that. And something that I don't have details on yet, but we're investing heavily in automating these systems' health, like the questions that people answer. So if I was starting this journey now, I would start with much fewer criteria and start with automation. So I wouldn't start with all the criteria we've got and make everyone fill out these forms. That's what we currently do, and that information is pure gold. It's amazing, but it's high effort. So we want to kind of pedal that back a little bit and automate as many as we can so that teams don't have to go through that effort of manually answering those questions each time. And so that just means those criteria will be really clear. A system recovery plan will be a certain file with a certain name with a certain structure. And so that you don't need to answer a question about whether it exists or what's in it. We can have tools that can do that. And so we're doing that through our software catalog. One of the huge things has been about trying to get buy-in through the organization. So we've got company-level OKRs around having healthier software and improving the health of our software. And our CEO, if we're not meeting those criteria, he'll jump on town hall calls and say, this system's health criteria, this objective, that's no less important than our revenue targets or our audience numbers. And so that's been really good. So over the last few years, this is when we made the criteria really objective, we realized that people maybe thought their software was healthier than it actually was. And so in 2020, we had this reality shock when we said, no, this is what the health criteria mean. A lot of people went, oh, actually, our software's not as healthy as we thought. And so that was a bit scary because we realized most of our software wasn't very healthy. But over a couple of years, we invested heavily and having these company-level OKRs helped with that. This graph is from the last time I gave this talk, and I was updating the talk last week, and I had to add on, another year of data. And that was scary because I thought, well, what if this graph looks really nice, right? It goes from mostly red and amber to quite a lot of green. What if it doesn't look good? But I added the next couple of years of data, and it looks really good. So that was a big relief for me. So the system is still working, the talk is still valid, which is good. And it's a combination of a lot of our amber systems turning into green, and a lot of new systems that we're creating are green. But there is a problem. And that's that there's a large set of red systems which seem to not be going anywhere. And it's not getting much smaller. And so in the current financial year, we've changed, our objective is about healthier software. Previously, the key results have just been around improve it by 25% over the year. But do whatever you need to improve it by 20%. And people did all the easy things and did all the easy systems. The really old red systems, they're the hardest to get healthy, and that's what's left. And we looked at why that is. One is the operational lens is much harder to get healthy. Having a really healthy system in production, that's harder than just getting a good dev environment. And so we've got a key result specifically around the operational lens. And we have one around decreasing the number of red systems, actually retiring those red systems. So I'll add another graph in a year and tell you if that's worked, but that's what we're doing at the moment. So that's the kind of system of continuous improvement. There's this minimum investment that we think you need. We think it's around 20%. We default to kind of 20% of a team's capacity. Automation is really key, and actually we're investing heavily in trying to automate this process over time. And broadcasting the data and the systems and having your executives understand how healthy your software is and investing in keeping it healthy has been really valuable. I'm not going to dwell too much on the platforms because I think there's a whole talk around how we do platforms. I think there's been some other talks about platforms. So let me just touch on, this is our approach to internal platforms. Probably another hat tip to the ThoughtWorks Tech Radar. They've talked about platforms as products for quite a few years. So we have an internal brand collab that's around a mindset shift from local to company-wide thinking, but also how we approach tech platforms as long-lived products. And we talk about collab as the building blocks that we build our tech with, and that means you've got less software and you're going to have lower entropy. So if you build things out of these composable building blocks, there's far fewer configurations of that. So in the physics world, that would have far less entropy because there's much less possible states. And so having these composable building blocks is really important. So if I just give you an example of our web platform, this is Hello Yao conference. I gave this talk at a different conference. The demo is still live. I forgot to kind of rip that down. But that's kind of all the code that you need to deploy a fully running React app on our main website with all the CDNs and monitoring and everything. And so that's all the code that you need. That platform, we've looked at the various teams. Maybe there's 20 teams or so that are building on top of that web platform. And what we're seeing is they need 35% less code, 75% less developer effort, 50% shorter time to market. So they're all great things for a platform. The one that I'm really excited about is this bottom one, is that it looks like it's 90% less effort to maintain. So that lower custodianship. That means that we can spend more time shipping valuable features to our customers. And the reason for that is, this is the same criteria that I showed you before. These are all the different things that we think you need to do to have healthy software. But actually, if you're running on that web platform, all those kind of faded out ones are mostly taken care of for you. So they're not things you need to worry about. So actually, all you need to worry about is the architecture is still important, the purpose and how your software is structured and interacts. That's still something you've got to do and really comes through with some domain-driven design and things like that. Making sure you do proper incident management when things don't go right. And multiple contributors, multiple deployments. That's just your team working on your software. You're always going to have to do that. But a lot of the other things are taken care of for you. And so that's just an example of, managing the health of your software and investing that custodianship is one thing, but trying to work out how to have less software in the first place is also really important. And that's where the platform strategy comes in. So, adopting platforms, that really helps the long-term fight against software entropy. Because they reduce the amount of software that you need to write and maintain, and they increase the structure. And these reusable building blocks, they reduce the total entropy that you've got. So that's those 4 things that we looked at and how we're fighting software entropy. I hope you'll see from looking at that, and even just thinking about the software in your own company, that software entropy is a very real and present issue in our industry. And I'd really say ignore it at your peril. If you leave software long enough, it does get unhealthy, and then you end up with doing these big bang rewrites. And this is kind of our playbook for how we fight software entropy, about getting the architecture right, the culture of engineering excellence, and defining systems health, having dedicated capacity for teams and architects to improve the health of their software, and then investing in platforms to reduce the amount of software that you have. And so, by getting this right, the structure defined, and investing the right energy, I hope that you too can fight software entropy. That's it. Thank you.
Stu, thank you so much for this amazing talk. As I mentioned to you guys, we saved the best for last. Stu, before we go into the questions, I have a little gift from Hungary.
Thank
for you. That's a little bit of paprika, a little bit of palinka, and a magnet for your fridge.
Very nice.
So you can show your kids. Just the magnet, not the alcohol.
Okay. If it makes them sleep, I'll do it.
Yes. Guys, I have to give you the last announcements of the day, and then we can jump to the questions, all right? The most important one is the closing keynote that is going to start at 5:40, so now.
Oh, sorry, I didn't realize we were
Actually,
late.
no, I'm wrong. It starts in 10 minutes, 5:50, okay? And yeah, that's the most important announcement. The rest of it, you already know, which is talk to our sponsors, go and use Slido for the keynote, so give the speaker the proper appreciation and ask the question while you already asked the questions. And I will see you tomorrow here at the purple stage at 10:30, all right? The talks throughout the day and throughout the conference, they are recorded and they will be posted in our webpage and into YouTube, as long as the speaker agreed to that. And last but not least, if you go to the relevant sponsor booth with the stamps, you can win valuable prizes at the CraftHub booth, all right? So that's it for announcements. Now questions. I do have questions. Robert asked you, how do you make sure the improvement of system health is not just a proof of Goodhart's law?
That's a really good question. There's been a few mentions of that today, that if a metric becomes a goal, it ceases to be a good metric. That quarterly system of assessing the health and reflecting on that, it has actually become a kind of an actual framework run by our risk and audit team. And so we actually audit the results now, not for 1,000 systems, but we go through every quarter and do an audit of a random set of systems and basically have external validation that systems are being rated appropriately. But I'll say the long-term answer to this is, if you automate it, it becomes very clear. You either meet it or you don't.
Great. Guys, I'm sure you want all of these questions answered, but we won't have the time, all right? I encourage you to find Stu afterwards also to ask the question. Just to be sure. Stu, do you have a short example for decision-making frameworks?
We have a couple. They're maybe not industry-wide terms. We have a thing that's essentially like RFCs. So if you're making a decision within your team, that's the boundary of it. Just make it, document it with a architecture decision record. That's really important. So we've got the record, but just make it within your team. Keep moving. We don't want to slow you down. But if it's going to have an impact throughout other teams, we have a process of essentially putting it up, getting comments, getting the appropriate stakeholders, and doing that. And then at a really high level, should our data platform be in AWS or GCP? That's a big decision that kind of bubbles up to a kind of a company level decision. But those things are quite rare. So most of them go through, we call it an interested party review, but it's very like an RFC. And then the ADRs documenting the decisions within the teams, very important.
Okay, I have these two questions might be related. So how did you measure how healthy is your software, and how do you balance system health versus business goals and value add?
In terms of how we measure the health, it's those questionnaires that we go through at the moment, although I hope in a year's time to be able to say that, you know, there's a bit of software that assesses it for you. What was the second bit? Oh, how do you balance business outcomes and this investment? We basically have an expectation of investing this 20% time. That doesn't mean that every month it's 20%. There are times when we've got specific deadlines. There's market conditions that mean, you know, we really want to ship certain things before spring because that's when most people in Australia like to sell their houses because the weather's nice. They don't like to sell it in winter. And so we do have very real deadlines, and sometimes we'll push hard for a deadline and do less of that custodianship, but the expectation is that over a period of months, that averages out. And I look at those metrics for all of our teams.
Thank you, Stu. Is there any particular book or source of information you recommend to learn more about managing healthy software?
There's not something specifically at this kind of system-to-system level and an architecture, but if you want to know more about the internal quality of your software at a code level, there's a book by a guy called Adam Thornhill. I think he's Swedish. It's called Your Code is a Crime Scene. It's good, yeah, it's a great book. Last conference I gave this talk at, he spoke directly before me, and so I got to reference a lot of his material. He's just about to release the second edition of Your Code is a Crime Scene, so it'll all be updated. So he does all, that's right? Yeah, so he does, and he writes like actual academic papers that validate that this is correct. So I'd say that's an excellent book.
Awesome. What do you think about vendor locking / potential mitigation strategies?
Vendor lock-in. Your cloud providers. It's hard. Like we've moved from being an AWS only shop to being a kind of a selective multi-cloud. So it's not just anything in any cloud, but our data platform runs in GCP, and a lot of our compute and kind of customer-facing stuff runs in AWS. So we've got a bit of, you know, we've got quite long contracts with those people around if that was to go away. But I think I'd rather use the high-level tools from those cloud providers and wear a bit of that lock-in. Although with things like Kubernetes, certainly compute is getting a lot more portable across different clouds. But it's definitely a challenge. I don't want to make people late for the keynote, by the way.
Question about the value, and it's somehow not here anymore. So if, you know, Stu is still up to answering the question, so if you want, let's put that again. And the last one is, what recommendation you have for a small startup that is prioritizing moving fast and expect to rewrite software because of changing business needs?
If you're a small startup and you're still searching for product market fit, I would focus on, you know, finding the right business fit and making sure you've got a sustainable business before worrying about maintaining your software. That's why we still have some Perl from the 90s, is because we're a Perl shop in a garage in Melbourne. We're now a kind of multi-billion-dollar company. So the decisions we make now around how long our software lasts is very different to what it would have been in the early days when we're a startup. So yeah, I think if you're a startup, just focus on the customers and the money at the start.
I have the best tech crew. You see, my battery ran out and I already got a new microphone.
There we go.
So, why 20%?
Why 20%? It's not actually because of the Marty Kagan blog. We found that later, and that was really nice because it gave us some credibility about the 20%.
I would guess Pareto principle, but whatever.
Could be. I don't know, actually. I wasn't involved in that decision. It felt about right, and so we did it and we measured it, and it still feels about right.
All right.
Yeah.
Based on which criteria are the unhealthy systems picked, and by whom in the org?
How do we choose the unhealthy? I mean, if you don't meet the criteria, then your software is deemed unhealthy. So it's the actual criteria are reviewed kind of once a year because they're part of kind of financial year level OKRs. We don't like to change the criteria during the year. We did that 1 year and everyone got very upset because they thought they were on track to meet the OKRs and their health changed. So we kind of changed it at the financial year boundary. So the set that I showed you now is a bit different to the set from a year ago because we've decided just to clarify certain things. But essentially, that you meet the criteria, you're healthy. If you don't meet the criteria, depending on how many, you get less and less healthy.
All right. Stewart, give me a high five. Thank you so much, guys.
Nice.
Thank you. I'll